Hello everyone. Previously we had discussed on the topic command pattern, right? So today we'll be discussing facade pattern, right? So here let's get into the definition part. The facade pattern provides a simplified interface to the complex subsystem. That's all it does basically. The facade pattern is very simple. It provides a simplified interface to the complex subsystem, right? So before getting into the example part, so let's discuss one of the important points here, right? So it hides the internal complexities. So this is very important. It hides the internal complexities and provide a unified entry point to interact with the multiple modules. So that's what it does, right? So here let's see this one with a very simple example, right? So first I'll just go with a class CPU here. So this is fine. So within the CPU class I'll just go with a start method. So let me pass self. This is fine. Let's print something for the interactive purpose. So I'll just go with CPU started, right? So this is fine. So let's go accordingly with the definition. So I'll just go with one more class here named memory, right? So name memory. Within this class I'll just go with a I'll just go with uh sorry I'll just go with a method load here. Let me pass self. uh let's print something for the again let's print something for the interactive purpose. So I'll just go with a memory loaded. So this is fine. So I'll just come out of this one entirely. Let me go with one more class, the last one. So I'll just go with class computer. So we have considered CPU and memory. Basically now let's consider the computer, right? So let's go with the initialization part here. First I'll just go with def. So this will be init. So we'll be going with a self. So let me remove pass here. Self dot. So we have considered CPU class, right? So I'll just go with a CPU. This one, this let's call the CPU class. So this is fine. Let me give parenthesis as well. One more thing, we have considered the memory class as well. So I'll just go with the self dot memory here. So this one, let me call the memory class here along with the parenthesis, right? So we are done with this part. So let's go with one last method, nothing but start computer. So I'll just go with def start underscore computer. So within this I'll just pass self. This is fine. So within this method let me go with self dot we have a CPU variable that's been used. So I'll just make use of the CPU dot. So I'll just go with a start. So this is fine. Let me go with self dot memory. So this is also fine. Let me go with load, right? So this is also fine. So let me go with a test. So let's test this one. I'll just go with the PC variable here or object. So I'll just go with computer. Let's call the computer class here. Let me go with. So we have made use of the start, right? So this is not showing here. Why? So yeah, this one has to be again indentation problem. So it would have caused indentation problem, right? So this has to be start computer. So this has to be equivalent to this one init basically. So this shouldn't be inside the initialization part. So this shouldn't be nested within init start computer method I'm speaking of. So basically start computer method should be same as this one init, right? So it shouldn't be nested to the init part. So I'll just keep here. Let me paste it over here. Start computer. This is fine. So we are done with the coding part, right? So if I run the code, the output that I need to get here is CPU started. First thing we have given here CPU started, and the second one we have to give here memory loaded, right? So we have to get the output CPU started and memory loaded in the second line. So let's check the same thing. I'll just go with the Python. Let me right click, rename, copy this one, paste it over here, .py. Right. So if I run this one, what is the output that we are getting here? CPU started, memory loaded. We are getting the correct output, right? So here, facade. So this one I'm speaking of. Facade, what it does here? Facade or the computer. This one, this class is nothing but the facade class, right? So facade or the computer. This simplifies the access to the CPU and memory. what it is doing, it is simplifying the access to CPU and memory. So the definition says same thing here. The facade pattern provides a simplified interface to a complex subsystem. So that's what the facade or the computer class is doing here. Again, the facade or the computer simplifies access to the CPU and memory. So we are getting the correct output. CPU started and memory loaded, right? So we are done with the coding part, right? So again, let me summarize whatever we have learned so far. So just keep this one point in the mind. So facade pattern is great for simplifying interaction with complex systems by exposing a clean interface, right? So that is what the facade pattern does, right? So this is one of the important patterns, right? So we are done with the facade pattern. Next we'll be discussing on the topic proxy design pattern, the last one, basically the last one in the playlist. So uh, there are more patterns, man, I wouldn't lie. There are many patterns as well. So these are the 10 important patterns, right? So the same thing we did in the JavaScript as well. So you can just look into this one as well. State pattern, you can just go with a chain of responsibility as well. You can just go with a prototype as well. Abstract factory, these are some of the patterns you can go, but usually we don't make use of it, right? So usually we don't make use of it. So these 10 will be usually making use of these 10 patterns, right? So that is the reason I have thought of making videos on these 10 patterns. And the final pattern, it's gonna be this one, proxy design pattern, right? So we are done with the facade pattern for now. This is it. Thanks for watching, guys.